Hello, and thank you for watching this video. I'm Wessel, and I'm part of the Enceladus Plus team, a group of students that, during the autumn semester of 2020, was part of LUdev. LUdev is a software engineering company run by students of the Leiden Institute of Advanced Computer Science, or LIEX, which is an institute of Leiden University. Let me give you a bit of background information. At LIEX, all students in the third year of their bachelor's degree take part in the software engineering course. In this course, students get hands-on experience with the whole process of developing software by working on a real-world project. At the start of the course, the students form teams and are assigned projects to work on during the semester. On the other side of the project is a client, which in some cases is some individual or group within the university, but in the case of Enceladus Plus, it was quite different. We developed software for CJob, a company employing 180 engineers spread over 7 offices all around the globe. CJob designs ships for some of the leading shipyards, and the portfolio contains quite a few advanced vessel designs. So what could we, a group of 7 students in the third year of the bachelor's degree, do for a company such as CJob? When we were assigned this project, we met and talked with Roy de Winter, data scientist at CJob. He told us that their clients, such as shipyards, usually list a couple of requirements when requesting a vessel design. However, these requirements are not necessarily the best for the challenges that a new ship is supposed to tackle. For example, a ship that usually sails with a speed of 20 knots requires a different design than one sailing with 30 knots. So if a client asks for a vessel that should sail at 30 knots, the engineers, of course, would like to know if this is a reliable estimate. This is the aim of operational profile analysis, project that we have worked on for the past couple of months. We designed a web application in which CJob's engineers can analyze data from ships that have already been operational. By looking at the behavior of similar ships, engineers can decide on the best requirements for a new ship design. In our application, CJob's employees can upload data and analyze this using 15 different visualizations. Examples of these are shown here. This is a map showing the ship's trajectory, with pop-ups showing relevant information. With a drop-down menu, not visible in this recording, users can pick the visualization that they would like to see. There are some common options, such as line charts and histograms, but also a few specific to the maritime industry, such as this heat map. Some come with tunable parameters to get the most out of your data. For some graphs, the users can decide which of the quantities to display. Datasets often have around 20 different quantities, so the possibilities are endless. Since the data is always provided in a specific format, the application knows what each quantity means and can easily read and interpret them. The application also enables the user to filter their data, so that they can focus on what is important. Filters can easily be imported and saved, so that users can quickly switch between their filters. Users can filter on each attribute and add multiple conditions per filter. Here, you see a histogram of wind speed on the Beaufort scale being filtered for values between 2 and 5. While working on this project, CJob gave us some examples of plots that are almost always relevant, and we have listed those in a set of presets, which quickly inserts the necessary data without the need of those extra clicks. An additional feature is that most visualizations allow for some changes to their layout, such as the names of the title on labels or the limits of the axes. When the user is finished, the graph can be downloaded as an image to insert in some kind of report, which can be sent to their clients. During this semester, our team had bi-weekly and sometimes weekly meetings with the client to discuss what visualizations, features, and options to focus on, and gave us the opportunity to report our progress. Between those meetings, we worked on the project using the approaches and best practices that were being shared in the lectures of the course. As such, we learned how the software engineering process worked while immediately being able to apply it to this particular project. Additionally, we all got experience with the software required for a web application such as this one. In short, the course offered a great combination of education and hands-on experience, and we're pretty sure that the client is happy with the end result as well.